Right, 2014 School Geometry Exam, question 2. Now hopefully you've read this. For us to find the radius of the circle, here's the radius. Obviously if you look at the diameter and consider the diameter, it's actually the hypotenuse of this right angled triangle. Now we do need to say why it's right angled. You would need to prove that that's a right angle in there. Clearly it is 90 degrees because it's an angle in a semicircle, and that's a circle geometry rule. So we would need to call that something. Perhaps if we label it A, B, C, and then we can say angle ACB equals 90 degrees, angle in a semicircle is 90 degrees. And now by Pythagoras' theorem, I can tell that AB, we might put that across to show it's the length AB, is going to be the square root of 9 squared plus 7 squared. AB will equal, so therefore AB .4017. Now we did want the radius, therefore the radius, which is AB divided by 2, is going to equal 5.7. We're in centimetres, and that's to 1 decimal place. Right, next question. Aeroplane in the sky at a distance of 7.2. The plane is an angle of 43 to the ground. How high above the ground is the aeroplane? So we're clearly looking for that side. Hypotenuse, opposite. It's a SO problem. So sine of 43, SO equals O over H. The opposite side is X. H is 7.2. It's a multiplying one. X is going to equal 7.2 times sine 43. You can be using the triangle method if that's easier. 4.91 kilometres, 2 decimal places. As long as you get the right answer, you try it with the triangle. Right, part C, we've got a ladder leaning against a wall. The bottom of the ladder is 1.6 from the wall. What angle does the ladder make with the wall? So we must be talking about this angle up the top here, because here's the ladder meeting the wall. So we're looking for that angle. I'm going to call it theta. The ladder is 5 metres, and we've just lost our 1.6 again. So this is the hypotenuse, this is the opposite. So once again we're looking at sine. So putting in what we know. So sine of theta, opposite side, hypotenuse, it's a division problem, sine theta equals 1.6 over 5. Now when we're looking for angles, I know we need to use inverse, sine inverse, and that equals 18.7 degrees, 1 decimal place. Right, we've got another ladder leaning against a wall. This question's a wee bit harder. A brace was added to the ladder 0.4 of a metre from the foot of the ladder, so that distance there must be 0.4. Brace is at right angles to the ladder and is bolted to the floor. What distance from the wall is the end of the brace bolted to the floor? From up above we can see that that angle is 18.7. Now what I've got is this little triangle in here, and I might just draw that over here. It's slightly larger, because it's a bit little there. 0.4. Now what I could do is that's 18.7 and that's 90, we could find that angle in there using angles in a triangle, add to 180. So 180 minus 90 minus 18.7 is going to give me 71.3. So that's that angle in there. And now if I could work out this side, actually x is probably not a good letter, we could call it y. For that side, I do know that that whole length there from the question above is 1.6 meters. So if I know the whole side, I could minus off this hypotenuse here, and that would give me x that I'm looking for. So this is a hypotenuse, this is an adjacent side, so it's a ka problem. We're using cosine, putting everything we know into the triangle, cos of 71.3, ka, a, over the hypotenuse. Now this is a division problem. So y is going to equal 0.4 divided by, which gives me 1.25, and therefore if I want to find x, it will equal 1.6 minus 1.25, 0.35 of a metre out from the wall. Right, that was an excellent question. We've got another difficult question to go. And it looks like a bearing one, so we're going to need a picture. Right, so starting, drives her boat at a bearing of 41 degrees. It's not very straight. For 3.2k, then on a bearing of 131. Actually, that's not very good either. 131, and then back to the start. Right, so let's see what other angles we know. Using our parallel lines, this needs to be 41, parallel lines there. And using angles on a straight line, 180 minus 131 gives me 49. Now the nice thing is, of course, that 41 plus 49 adds to 90, which makes a right angle. You do need to show that though. So now that I have a right angle, life is good. So if we start with part 1, how far did she drive the boat on the second leg? Using some Pythagoras, hypotenuse squared minus the other short side. We're using subtraction to find the short side. 4.22 kilometres, 2 decimal places. You should just check that on your calculator. Now it wants what bearing did she travel on to return to the boat ramp. So bearings clockwise from north. We want that angle there. Now I can see that that one is 49, alternate angles. We could work out theta in here, and then once I've got both 49 and theta, we could subtract them from 360. So let's think about finding theta. Use the sides we've already got. This is the hypotenuse. This one is opposite theta. Hypotenuse and opposite is sine, so. So I've got sine theta, so, opposite side over the hypotenuse. We need some working. Inverse, of course, if you're looking for an angle. Extra digits there, I'll leave them on the calculator. So the bearing will equal 360 minus 49 minus theta that we've just written down. Working all that out, 273.86. And we might round that to 274 to 3 significant figures. Right,